a big first step. But now that we have this system in place, let's take a look at actually what's going on a bit under the hood. All right. So we start off with 8 points, and we copy it. Okay. And duplicate that again, merge it together, copy it again. Now, a few questions have been raised, like this is not instancing. Instancing is when we take a procedure and we're basically swapping out, the input of that procedure. Okay, we're replicating kind of what something is in another form, and that's really not what we're doing here. Here, what we're actually doing is we're actually taking in geometry data and we're brute force copying it. Now, it has its advantages and disadvantages. There's digital assets in Houdini, which is basically you make your own node. That's kind of like instancing in other programs. There's also point instancing, which means that you just give it a collection of particles, and you could, like, at render time, put objects on those particles. So there's a few different ways to do it in Houdini, but right now we are definitely not doing a Maya or Max instance. Okay. So middle click on geometry. That's a really important thing to be used to. Right now, this tells me a lot about it. Okay. It tells me that I've got 800 points. I can view those like this. I can see the point numbers here. Okay. Here's the polygon numbers. Okay. All I really have here, though, is just primitives and points. Primitive is a surface in Houdini. A point is a point in space. That's different than vertices and polygons. Polygon is actually connecting vertexes together. So vertexes and polygons are very concrete. Points and primitives are very abstract. Okay, so that'll make more sense as you get farther into Houdini. For right now, just keep that separation in mind. So what I'm going to do here is I'm going to do what's called a point attribute. All right, so I'm going to click on here, and I'm going to do a very cool node called a connectivity. And this is going to introduce us to the concept of an attribute in Houdini. Okay, connectivity. Now, notice that it says connectivity type is point. And the attribute right now is class, but I'm going to change this to something meaningful called like brick ID. Okay. So why would I want to call something brick ID and not class in my system? Well, I renamed it from class, which is the default, to brick ID. Why would you want to design a system with something called brick ID?
So you can reference individual.
So like what if you have a few coming in from different places? You want to know, like, okay, this is a brick ID, this is a fence ID, you just want to keep stuff straight so it's easy to look at and organize and stuff. So this would be another local variable, okay? But it's a local variable that exists on geometry data, all right? So right now, then if I middle click down here, I can see, yes, I have position, but I also have this brick ID guy, okay? Here's my spreadsheet. I'm gonna right click on the node, go to spreadsheet. This tells me all of the exact pieces of data that are contained in my geometry. I've got point data, vertex data, primitive data, which I don't have any, and detail data. Okay. Now we're not going to get into these guys yet. Just point data for now. Okay. So here's all the positions of point number 93. I can tell what its X, Y, and Z position are. If I go down here though and look at my connectivity, then I do my spreadsheet. Notice it's got an extra piece of data over here. All right. So it's got that brick ID that I just made. So if I go down here, whoa, it's changing numbers. Okay, so what this connectivity guy does is it will look and see what is attached to what, and then it'll assign this value in a numbered order. So the first brick, wherever it may be, would be 0. The second brick, since it's not connected to the first brick, would be 1. The one after that would be 2, and so on. Okay? Because if we look at this right now, it would be really hard to make these bricks individual colors. Like we'd have to like select them all, you know, one by one, and try to, you know, do some kind of a color operation on them. And this would be a workflow that might be used for small numbers of things in other programs. However, since we have a lot of bricks and we want to be procedural about it, we're going to be procedural with our geometry. We're going to assign this brick ID point attribute. Okay? So after that, I'm going to put probably the, I would say, yeah, I would almost say this is the most used node in Houdini, the point SOP. Okay, so this point SOP, it looks scary, but it's really not. It's really not bad. It's really just a way to change things on a point-by-point basis. Okay, so if I wanted to, I could add a color attribute. I could add normals. I could manipulate ty, which is the position for the y of point. So if I do ty plus 2, I'll move all of these guys up by 2 units. Like that. Okay?
Andrew?
Yes.
Did you hit record on the annotation?
Yes, I did.
Okay, awesome.
Yep. So yeah, this is the local variable on the on each point for the y, and then I'm adding 2 to it. Does that make sense? All right. So if I wanted to change the color, all right, I'm going to put this back to this color. Okay. All right. We could just make them all red. But since I have this neat brick ID, we can actually use brick ID to color them differently, right? Because it's a different brick ID for each brick. So let's try $brick ID times 0.05. Well, look at that. See what happened? Why did it do that? Which one's the first brick? This one, right? Because it's 0. So it'd be 0 times 0.5 for the red. All right. Let's try like a 0.05. There we go. So we have more of like a gradient going on now. So you can see like the order that the bricks are going here. Okay. Let's do something a little bit more interesting with it though. I'm going to use an expression. Okay. So this will be our first expression. I'm going to use random expression. So random, sorry, caps lock. Okay, random. So I type in rand and it tells me how to use it. Okay, so it just wants a float value. Does anyone know in a random sort of thing what it needs a value for?
This is a pseudo-random generator, right? So it
Yes.
needs a seed ID.
Yes, this is called a seed. Okay, so a seed is basically, it's kind of like a seed of a tree, I always think about it. So you put a seed in the ground, it's going to come up with a tree, but you don't know how the branches are going to go. You do another seed, it's going to come up with a tree that looks almost the same, but it's going to have a different assortment of branches, right? So that's exactly what a seed does here too. This random expression is going to give me a value between 0 and 1. But depending on what seed I put here, it's going to give me a different value between 0 and 1 each time. It'll be the same value. If I put in 0.5, it'll always be the same random value. Okay? If I put in 0.2 and 0.5, it'll be 2 different random values. So if I put in, say, random 0.5, they're all the same. If I put in 0.25, it's not quite all the way red, is it? It's a different It's a different value. Let's see what value it is. 0.3. It gave a different random there. Now if I put random brick ID, look at that. See? So it colored each of these bricks points differently because each of them have a different brick ID. But the reason that this point is the same as this point is because we're using brick ID. If I do random $PT, which is the local variable for the point number, okay, it's going to be a completely different value for each point. That's really not what we want, right? So we want a different colored brick. We don't want a different colored point by point by point, right? Okay. So random brick ID plus 0.01. Then I'm going to go to the next parameter for the green. Random brick ID plus 0.02. I'm just giving it a different seed here. That's all I'm doing. Then random for the blue. Brick ID plus 0.03. All right, now we have every color of the rainbow. All right. So, what just happened there? I know that was a lot for just 2 nodes, right? But we have our brick wall. They are not connected to each other. So I use a connectivity and I add a point attribute brick ID. I use this brick ID point attribute in my random expression of the point of the color of the point SOP. Okay, questions?
Yeah,
Yes.
So could you also link in like different shaders based on brick ID?
Yes.
Okay.
So we could either use this color directly, because this color is actually another attribute. We could use CD, and see this has our color information on it now, and that's by default used in a shader. So here's CD, and I'll just give this like, oh, I'll just hit render. Hope it doesn't crash. There we go. So by default, the color is used in the default shader.
Okay, so it injects it into whatever shaders.
Yeah. However, we don't have to do that. Like, we could actually use brick ID directly in the shader to do something else. We'd have to wire stuff in and say brick ID, but yeah, any shader you write in Houdini can access that point attribute.
Okay.
Yeah. All right. So add your brick ID. Use your expression with the brick ID. Okay. Now it doesn't have to be the way I did it. You can come up with other funky things on your own. Like say you wanted this brick ID to be brick ID modulus 3 or something like that, and that would give you different assortment of. Let's try 2. Not so much. But anyway, let's try out an expression with our brick ID. Okay. Connectivity, point SOP. Any other questions before we do that?
Is there a way for me to see a list of the operations and random?
Ah, yes. Okay. So once again, now this help is not as straightforward as, of course, node-based help, because it's an expression lives independently of nodes, right? Like we can use the random expression in a different node if we wanted to. But yeah, if I type in, expression, here's the expression functions, and here's all of them. All right.
There's lots.
But the good thing is,
But it doesn't explain how to use them, right?
it does explain how to use them. Let's see, rand. Okay, so that'd be R. You have to know alphabetical order. That's the downside. All right. Rand. There we go. It'll tell you how to use it. Okay. Give you an example. The good thing is that once you know expressions in Houdini, a lot of these are very similar in Nuke. Okay. So, like, there's referencing and there's random and that kind of thing in Nuke as well. Right? Or most other programs that use expressions, they're not going to be drastically different than the way these expressions work. They're gonna, maybe instead of rand, they'd say random, but they would work basically the same. Okay, how is the random expression in nuke? Is it?
I think it's just like that. Target ID.
Okay, so we know this. We know the same thing in nuke then, right? Cool.